mission was called the Moon God Awakens, and it deployed a radar imaging satellite named Tsukuyomi-1. Today, it's the Lightning God's turn as we launch the first of 8 new missions for the Japanese Earth Imaging Company.
Across these 8 launches, Electron will expand IQPS's constellation of SAR satellites. These aim to provide persistent monitoring of Earth at fixed points every 10 minutes. Inside Electron's fairing is a single spacecraft, the QPS-SAR 9 satellite, and it's headed to a 575-kilometer orbit. Let's hear more about their mission from the team at IQPS.
QPS-SAR project. The future begins in Kyushu. Maximum ground resolution of 46 centimeters. World-class image data enables observation of moving objects like cars and ships. QPS-SAR, a 100-kilogram class small SAR satellite. A constellation of 36 satellites will observe almost every location on Earth every 10 minutes on average. SAR satellite.
We're 14 minutes away from sending that QPS-SAR 9 satellite on its way to orbit. So for now, let's take a look at some of the numbers behind the launch vehicle that will take it there. So today's launch is our second for IQPS out of a total of 9 Electron missions that they have booked with us. It's also our third launch of the year so far, but our 61st Electron mission overall. And that includes our suborbital Electron variant, HASTE. It will be our 57th liftoff from Launch Complex 1, since we've carried out 4 missions to date from Launch Complex 2 in Wallops, Virginia.
Each Electron has 10 Rutherford engines total. That's including 9 on the first stage and 1 on the second stage. So you'd probably think that means that we've sent 600 Rutherford engines to space, or 610 after today's flight, but that's where you'd be wrong. We've recovered and reflown one of those engines before, bringing the total number sent to space so far at 609. Since our first launch in 2017, we hit 50 launches faster than any other commercially developed rocket in history. We also deployed well over 200 satellites to orbit. This year, we have more than 20 missions booked on the manifest, so we're quickly adding to that deployment tally. No doubt you memorized all those figures and ready for the quiz at the end of today's broadcast.
But for now, let's give the numbers a rest and listen in for some very simple words instead. Go or no go? And that is the question our launch operators in Mission and Range Control will be asked shortly by Launch Director Paula Teres-Serralonga. They'll each report status on the various vehicle, ground and range systems they are responsible for, confirming whether or not they are clear to proceed with today's liftoff. So let's listen in for those calls now.
Control stations LD in Mission Core proceeding with go, no go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Vcon.
Vcon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
is go.
LDSAP.
LDSAP is go.
Go, no go sequence complete. We are T minus 11 minutes, 21 seconds and counting. We are go for terminal count auto sequence at T minus 10 minutes. From this time, the 3-word procedure is in effect.
That is go for launch from Mission Control, and we are proceeding with the count for an on-time liftoff at 1 p.m. local time today, just over 10 minutes from now. Now, today's mission has a 2-hour window, so should we need to adjust the T0 slightly for weather or any other reason, we have plenty of opportunities to do so.
While today's mission is all about sending something up to space, we recently completed a highly complex mission that did just the opposite. Our Pioneer spacecraft supported the re-entry of Varda's in-space manufacturing capsule, enabling it to land safely in South Australia. It was our second re-entry mission for Varda using our Pioneer spacecraft. And here's how we did it.
In-space manufacturing may sound like science fiction, but together, RocketLab and Varda Space Industries have made this a reality. Here's how. Across Varda's 4 missions, our
Recently, our third Pioneer spacecraft for Varda was integrated and is shortly awaiting launch. So looking forward to another re-entry in the weeks to come.
Now, today's mission profile follows the standard launch sequence you've come to expect from orbital Electron missions. So after liftoff, Electron will move through max Q, main engine cutoff, stage separation, second stage ignition, fairing separation, and battery jettison before second engine cutoff and separation of the kick stage that carries the IQPS satellite. Now, that full sequence takes less than 9 minutes, and then we are in an elliptical transfer orbit. And from there, the kick stage and the payload coast around Earth for around 40 minutes or so, before a final circularization burn that takes us to a 575-kilometer orbit for final payload deployment. Now, there's one part in particular about that launch sequence that will be quite different for our new launch vehicle, Neutron, and that's the fairing in the stage 2 separation. So on Electron, the two halves of Electron's fairing split and fall away, completely ejecting from the vehicle to expose the payload to space, but it's a little bit different for Neutron.
Speaking of Neutron, since our new vehicle is designed for maximum reusability, we've taken a different approach with its fairing. Neutron employs a hungry hippo fairing where the two halves open wide and make way for Neutron's complete second stage plus payload to pass through and continue the mission to orbit. The fairing then closes back up and remains attached to the first stage so the whole system can land back on Earth and be reused. We recently ticked off a big milestone in Neutron's development with the successful testing of this fairing actuation. Let's check it out.
The great thing about Neutron is that we took all the experiences that we had with Electron and rolled that into Neutron. So, a lot of launch
In action on Neutron's debut launch soon.
For now, though, back to today's mission, and we would like to take this opportunity to introduce you to a new team member here at RocketLab in Mission Control. So meet Alex. He is an avid space fan who let the good folks at Make-A-Wish know that it was his dream to be able to see a rocket launch and to have a tour of our rocket factory. And we were only too happy to help make that happen. It's an honor to have Alex and his family joining us in Mission Control today for launch.
Looking forward to it, Alex. All right, T-minus 3 minutes and counting. And as we approach T-minus 2 minutes, Electron will enter the auto sequence and the vehicle's flight computer takes over. In those final few minutes, you'll hear the various call-outs from Mission Control as final checks and procedures are completed for liftoff. Let's listen in for those calls now.
From now, there should be no red flags on your critical LCCs, Vicon, LD, and mission cord.
LD Vicon.
Vicon, lock the auto sequence and confirm.
Locked.
And Vicon, confirm all flight computer ASCOs are green.
All flight computer ASCOs are green.
Understood, thank you, Vicon. We are go for auto sequence start at T-minus 2 minutes. LDs go for launch.
The vehicle is fully on internal power. FTS is green and available for flight.
Box load is complete. System is in recirculation. Anti-geysering is disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
High flow engine purge enabled.
T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Beginning pitch up.
Stage 1 propulsion nominal.
Okay, the lightning god's reign has begun and we are on our way to space. Electron has lifted off from Launch Complex 1, cleared the pad, and is now traveling at over 800 kilometers per hour as it propels IQPS's satellite towards orbit. Now, one of the next calls you'll hear from our operators is Max Q, and that's the point in flight when Electron experiences the highest aerodynamic loads. Let's listen in for that call.
Cleared Max Q.
Well, that's Max Q behind us, and Electron is continuing its way to space for our 61st mission. Electron is now at an altitude above 17 kilometers, traveling at speeds past 2,400 kilometers per hour. Up next, in quick succession, we have MECO. That's main engine cutoff, which is when the first stage engines shut down. A few seconds later, Electron's first and second stages separate. At this point, Stage 1's role in the mission is now complete. But it's just getting started for Stage 2.
Shortly after separation, the single Rutherford engine on stage 2 will ignite, and that will propel us the rest of the way to an elliptical transfer orbit. So watch closely to see all of this take place in the next few seconds.
Stage 1 propulsion holding nominal. Stand by for MECO in 30 seconds.
"15 seconds to staging." Enter burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
And as planned, that sequence of milestones is now complete, and Electron's second stage is continuing to orbit. Now it's the fairing's turn. The two halves of the clamshell fairing will separate and fall back to Earth, exposing the IQPS satellite to space for the very first time. Those fairings, like the rest of Electron's structure, are made from carbon composite, so they're incredibly lightweight but also strong. It's why we're making Neutron's fairings from the same material. But unlike today's fairings, Neutrons will stay attached to the vehicle for landing and rapid reuse.
Fairing jettison confirmed.
And there we have it. Electron's fairing has been jettisoned, and the QPS-SAR 9 now has its unobstructed view of its new home in space. We are now coming up to 4 minutes into the flight, with less than just a couple more minutes remaining in this second stage burn.
Guidance is nominal.
When it comes to launching rockets and spacecraft, we don't just build, then fly. We rely on rigorous test campaigns to ensure mission success. For new parts, we start with development testing, followed by design qualification, or qual. Qual testing stresses the design far beyond expected conditions it would endure for a nominal mission, with vibration, shock, thermal cycling, and thermal vacuum, or TVAC, being a handful of test examples conducted. Next up is acceptance testing, intended for real flight article hardware. These tests are typically less harsh on components versus qual as to not fatigue them. After all, these are being used on actual mission. The aim is to catch workmanship issues and performance variances. For Neutron, some Electron components are reused but require additional testing due to the high acoustic and vibration levels from the more powerful Archimedes engines. The scope of Neutron's test campaigns cover individual components in isolation up to large integrated tests to ensure various systems, avionics, software, mechanical fluids, propulsion, all work together as expected. That includes tank pressure tests, engine hot fires, and as shown earlier, the hungry hippo.
All right, back to the mission you see on your screen. And next, we are getting ready to hear some of our 4 favourite words: battery hot swap successful. And that will mean that we have reached the point in flight when the depleted batteries that power Rutherford's electric fuel pumps are ejected from the second stage. We then immediately swap over to a fresh set of batteries to get us to the rest of the way to orbit. And that's why we call it a hot swap, since it happens while the engine burn is still underway. So as well as hearing the call out from operators, you should also be able to see the shiny silver batteries fall away from Electron on your screen. So eyes and ears at the ready for that flight milestone.
HGB discharge holding nominal, approaching hot swap in roughly 30 seconds.
Throttling down. Battery jettison confirmed.
Confirmed that swap successful.
Okay, in the eternal words of InSync, we have said bye, bye, bye to those batteries. A fresh set has taken over with just a few minutes now remaining in the flight. And the average orbital Electron mission takes around 9 minutes to reach orbit, which means across more than 60 missions, we have spent more than 9 hours capturing views like this one on our multiple journeys to space. And still, I tell you what, it's a view we never get sick of.
With just over 7 minutes completed in today's launch, we have passed through most of the key milestones with just 2 more remaining. That's SECO, or second engine cutoff, and stage separation. This is where Electron's kick stage separates from stage 2 in preparation for payload deployment. But before that, we've still got a few minutes to watch that Electron's nozzle glow brightly before shutdown.
Okay, T plus 7 minutes, 47 seconds and counting, and everything is proceeding nominally so far. The operators in mission control continue to monitor vehicle systems closely as we approach that all-important throttle down and the second engine cutoff ahead of kick stage separation. Now, if you're keeping an eye on our speed, you want to see that dial at around 27 to 28,000 kilometers an hour, which will indicate that we have hit orbital insertion speed.
HEB discharge holding nominal.
Electron's 61st flight is coming to an end in just a few moments. We're now expecting to hear the call out, burnout detect mode, from mission control. Once we hear that call, you'll know that second stage shutdown is close.
20 seconds remaining.
SECO confirmed.
Nominal transfer orbit achieved. Stage separation confirmed.
And just like that, Electron's second stage engine has shut down as planned, and the kick stage is now separated to continue the rest of its journey ahead to payload deployment. Now, the kick stage will enjoy a gentle coast around Earth before it reaches its apogee, which is the highest point in its orbit. At that time, the 3D printed Curie engine on the kick stage will ignite and then raise the orbit to a circular one at 575 kilometers above Earth's surface.
Once in that circular orbit, it will be time to wave goodbye to IQPS's satellite as it joins its siblings in orbit. We'll come back for that Curie burn and deployment, but for now, let's take a trip down memory lane and look back at our very first launch for IQPS back in 2023.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
So on that mission, the moon god awakened, but today it is the lightning god's turn. And remember, today is launch number 2 of a total of 9 booked by IQPS on Electron. So many more views like that one are coming up in the next few months and years.
For now, though, let's take a break while the kick stage moves into position for deployment. We'll be back with you in just a jiffy.